Good evening, Sahitya.
Good evening, sir.
Just 1 minute, let everyone join. Okay, so today we'll be starting with the chapter Reproduction in Animals. All right, we'll start with a new chapter Reproduction in Animals. All right,
Okay, sir. So what are we doing, sir, now?
new chapter today Reproduction in Animals.
Good evening, sir.
Yeah, good evening.
Sir. Okay, sir.
Yeah, what happened? Physics class. Okay, does ma'am take your bio class?
Yes, sir. Manisha ma'am takes a bio class.
Manisha ma'am takes bio class. So, when does she have bio classes?
Saturday, sir.
Saturdays. Right. So cell structure functions she has taken, reproduction animals she will be taking, reaching the age of adolescence she will be taking. All right. Okay, we are left with sound and light. All right. Sound, some natural phenomena, light. Okay. So which two chapters should we start with? Sound or light? Let's start with light only.
Okay, sir.
So let's start with light. Yeah. So light. Please stop doing this. Just erase out of here. Okay. So this is how we define light. Light is a form of energy which causes sensation of hearing. So sensation of sight, not hearing. So light is a form of energy which causes in us a sensation of sight. We are able to see the things because of light. Also we can define or we can say light to be, we can also say that it is electromagnetic radiation or electromagnetic wave. Right. So we can say light is an electromagnetic wave. That means it is a wave which consists of oscillating electric and magnetic fields. So light is an electromagnetic wave. It consists of oscillating electric and magnetic fields. So when I say light, we generally mean about the visible light. So visible light, when we are talking of light, we are mainly consisting ourselves or considering ourselves for the visible light, visible spectrum, which we call as VIBGYOR. So this is the visible spectrum which we are talking of. Visible light. So the visible spectrum is also called as VIBGYOR. We call it VIBGYOR, where V stands for violet. I think everyone knows this. The 7 colors of light. So our white light, which consists of all of these 7 colors. Okay. So they constitute the visible spectrum. That means out of all the light, we are able to observe only this much visible spectrum. So we define light using 2 characteristics. The characteristics of light, which we say, let's deal with characteristics of light. Particle nature and wave nature. So this is just for your knowledge that light, it was long thing, a fight going on that how the light is working, what is light. So it was later confirmed that light consists of tiny particles which are called as photons, and light has a wave nature also. That means light travels from one place to another in the form of a wave.
Sir, what is the particle nature? Like, do you have to write characteristics of light, particle nature, and wave nature? And there is some points on that.
Okay, see, how do we know what is light? Okay, so according to some of the scientists, it was initially considered like Isaac Newton. आपने देखा? Isaac Newton, he considered light to be made up of tiny particles. All right. Then later on, after some of the experiments, it was shown that light is a wave. Light is working like a wave. Okay. Then after a few experiments, it was confirmed that light has both the particle nature as well as the wave nature. That means if you have a beam of light, so that light consists of these tiny packets of energy which are called as photons. So light consists of these tiny particles which are called as photons, and light also travels in the form of waves like this. Both the nature they are available with the light. So now it's known that light consists of both particle as well as a wave. So here, and also all of us know that light is the thing which can travel fastest in the universe. Light can move the fastest. There is nothing which can move faster than light. All right. So what is the speed of light in vacuum? Yes, can anyone tell what is the speed of light in vacuum?
In vacuum, sir.
वहाँ पे. What is the speed of light in vacuum?
Um,
3
sir,
lakh kilometer per
yes.
second.
Yeah, it is 3 lakh kilometer per second. But the exact value is like this. It is 299,792
458.
458 meter per second. Okay. So this is approximated to 3 multiply 10 to the power 8 meter per second, which you can also say to be in kilometer per hour. This as 3 lakh kilometer per second. All right. So this is the exact value of the speed of light, and there is nothing in this, nothing over there in this our galaxy that which can move faster than light. So light is what it moves the fastest. Now say, with the help of the light, we are able to see different objects. How we are able to see objects? Our next topic is how can we see different objects? Gagana, Zubair, Saiti, are you there?
Yes, sir.
Please turn on your cameras, everyone. Everyone, please turn on your cameras. So how we are able to see different objects? How we see? So suppose when we see a tree or any object, so how we are able to see this? Let's say you have a tree or you observe a building over here. How can we see these objects? See, when some light, okay, when light from some source fall on this, suppose light from somewhere falls on the building, light falls on the tree, and after bouncing back from those objects, that light enters our eye. So when the light enters our eyes, we are able to observe these different things. So how we are able to observe the things? We are able to observe the things when light gets reflected or bounced back from different surfaces. Right. So this phenomena of bouncing back of light is called as reflection. Okay. So here we learn the definition of reflection of light. So what is reflection of light? It is the bouncing back of light. And also, is there anyone who takes your chemistry classes also? Charante?
No, sir. There's nobody that takes our chemistry classes.
Okay, so I only took up whatever part has been taken, all right?
Yes,
Okay,
sir.
so
You
after doing the chapter light, I'll move on to the other chapters of chemistry which may be remaining.
okay, sir.
Sir, I have a doubt, sir.
Yes.
Sir, you said that light is observed in different ways, like in which one sees the light as a particle, another sees it in the wave form, sir.
Hmm.
Like, what is a wave, sir? Is it also made up of particles?
Uh, that was confirmed by de Broglie. Okay. So that according to the de Broglie, that every particle has a wave nature, or every particle can show a wave nature. Okay. So if light is a particle, it can also show a wave nature. So what is a wave? Like we see sound as a wave. You can observe waves in a rope.
Sir?
Yeah, if you just take a rope and try to create a pulse in that, so that becomes a wave. All right.
And the
So
chemical effects of electric current come under chemistry.
which one?
Chemical effects of electric current.
Chemical effects of electric current that come under physics.
Okay, sir.
And we have that some natural phenomena also under physics. So
Okay.
anyways, I'll be taking up all the physics and chemistry. I'll be completing that. All right. So here you have reflection of light. Reflection of light means it is the bouncing back of light after striking a surface. So whenever light strikes a surface, we call it as strike a surface and it bounces back. We call this phenomena to be reflection of light. So reflection of light, it occurs in everywhere around us. Like just I told you over here with the trees and buildings. When light from sun or from any source falls on them, okay. So after reflection, that light reaches our eyes. Okay? So when the light reaches our eyes, we are able to see these objects. Okay? If the light doesn't get reflected and fall over here, so we are not able to see those objects. Alright. So now we'll study here two types of reflection. Is there anyone who has not understood reflection?
No, sir.
Okay. So there are two types of reflection which we say as a regular reflection or irregular reflection.
Sir,
Yes.
like what pushes the light to reflect, sir?
What pushes the light to reflect? Okay.
Sir.
Okay. We consider even if we consider light as a particle. Okay. So or light as a wave, it can also be explained. But we'll just try to explain it how the reflection occurs. Okay, just 1 minute. So considering light as a particle, all right. If I consider light as a particle, so we have, let's say, we have a surface over here, and on this surface, a beam of light is incident on it. So consider a beam of light falling over here. So we can assume that there are a number of particles which are falling on this. Okay. So due to this impact, there will be they will cause some amount of force on this surface. As a result, they will experience a reaction, and because of the reaction, they will be reflected back.
Like, is there any force where the object applies to the light, sir, to reflect back?
ठीक है, रहता है। आजा आजा मतलब अग्रवाल का चल के तुम मिल चलो, ठीक बात। Yeah. So see here. So see, for the reflection of light, we consider light to be made up of particles. These particles come and strike on the surface. As a result, they will also experience a reaction from the surface. So when they experience a reaction from the surface, they
Which
are
way,
bounced
sir?
back. Yeah.
In which way they experience the reaction?
Through which way? That can be shown. That can be shown using the laws of physics. That in which direction will they experience a reaction? All right. So considering action and reaction only, they are moving in this way.
Like, I'm not asking the direction, sir.
Yeah.
What is the, you said, sir, some forces there on the surface to make it reflect, no, sir. They will experience such a force, sir.
Yes. Yes. So that is
Like,
the
which force
that
is it, sir?
that is the force of reaction. We call it as a force of reaction. As
Okay,
we know,
sir.
for every action there is a reaction. Okay. For every, as per the Newton's third law, for every action there is equal and opposite reaction. So when a ray of light, when some particles fall on the surface, so they hit the surface with a certain force. uh, They hit the surface with a certain force. As a result, the surface also hits the photons back with the same force. All right. So they are bounced back.
Sir, I have heard that photons have no mass, sir.
Yeah.
I heard that photons have no mass, sir.
Yeah. Photons don't have any mass. The rest mass of the photons is zero.
But if we consider photon as a particle, then like it will be made up of something, no, sir, like electrons and protons.
No, no, no. Photon is just a packet of energy. Okay. Photon is a packet of energy only. They have rest mass as zero.
Okay, okay.
Okay. So see the types of reflection. We observe here two types of reflection: regular reflection and irregular reflection. So in the types of reflection, we will see a regular reflection and an irregular reflection. Irregular reflection. All right. So for the let's see what is a regular reflection and what is a irregular reflection. A reflection which takes place from a smooth polished surface. So you have a smooth polished surface over here, and if a ray of light comes and gets reflected from this surface, so such a reflection we call it as a regular reflection. So you have a parallel beam of light falling on this smooth polished surface. So all the rays of light, they get reflected accordingly. So this is a type of reflection which occurs from a smooth polished surface. This reflection is called as regular reflection. Got it? Then you have an irregular surface. So the reflection that takes place from an irregular surface, like this one. Let's say this is an irregular surface. Now the light will be falling at different surface, at different points, and accordingly the ray of light gets deflected. So you have a ray of light falling here, a ray of light falling here, a ray of light falling here. Okay. So the ray of light falling at different places, it gets reflected along different directions. Okay. So such a reflection is called as an irregular reflection. Okay. Got it? Understood this irregular reflection?
Sir, once can you
Yes, sir.
explain regular reflection?
Okay. A regular reflection. A reflection that take place from a smooth polished surface. A reflection that takes place from a smooth polished surface is called as a regular reflection, right? Whereas a reflection that takes place from irregular surface or rough surface.
Sir, I have a doubt, sir.
Yes,
Sir, we say that black absorbs heat more and white absorbs less heat, no, sir. Why, like,
yes.
what is there to do with the color, sir?
Okay, just 1 minute. See, we observe or we know that the reflection which occurs from a black surface or black color, it absorbs the maximum amount of it, and a white color, it absorbs the minimum, it reflects maximum amount of light. All right. See, all the colors which we see, as we know that there are different colors. We have the Vibgyor, violet, indigo, blue, green, yellow, orange, and red. Right. A combination of all the 7 colors gives you white light. All right. This is what we get as the white light. So when you observe something to be white in color, it means that it is reflecting all the colors. Then only you are getting it to see as a white color. Okay. Or if you see anything to be green color, it means it is absorbing all the colors and it is reflecting only the green color.
Yes, sir.
Okay. So similarly, when you see something as black color, so it means it is absorbing all the colors. All right. So it means it is absorbing all the colors. It is not releasing any amount of any light, or it is not allowing any light to escape from. Okay. So now you understood why it is related with colors. Yes. Okay. So understood this regular reflection now. Whose doubt was there from regular and irregular reflection?
Sir, uneven surface means
Yeah, uneven surface means a surface which is uneven. Okay, just like this. Take a look at this. I'll just explain you. Mm, mm. Okay, just I think you
So
must
it's
have
like a
observed.
surface with more irregularities.
Just 1 minute, 1 minute. I show you. I'll show you what it is. So this is what we see. Something, okay. Okay. See a stainless steel plate. So if you observe a newly bought stainless steel plate, so are you able to see your face in this plate? Whenever at your home you buy some new utensils like this. So are you able to see your face in that?
Yes, sir.
Yes or
Yes,
yes?
sir.
And
Yes,
why it is like here also, even if the pictures have been taken, so you can see here some reflections or some images are there. All right, you can see here also, you can see someone's image is here. So whenever you take some stainless steel plots or some utensils which do not have any scratches over there, so you are able to observe, you can see your face in that. Okay, what about after a few days use?
Sir,
Yes.
sir, after, like, this is the new stainless steel plate. After its use, we cannot see the reflection of
Yeah,
us, like,
yeah, you can't see your face in that. Why it is so?
sir, as it's
Yeah, we are not able to see as the utensil develops some scratches in that, which makes the surface to be uneven. Right. When the surface becomes uneven, then the reflection that occurs from it is an irregular reflection. Okay. So when the reflection occurs from it is an irregular reflection, so then we can't see our face. Got it? Okay, what do you think, which type of reflection would be occurring from a mirror, from a plane mirror? Yes, which type of reflection will occur from a plane?
regular reflection.
Yeah, regular. Okay, that is a regular reflection, right? Understood, everyone?
Sir.
yes, sir.
So I think we have understood about the regular and irregular reflection. Now it's the time we learn about the laws of reflection. So these laws of reflection are very important to understand this whole chapter. So the laws of reflection. Okay, so what are the laws of reflection? You have here two laws of reflection. According to the first law of reflection, uh, the incident ray the reflected ray and the normal all lie in same plane. Okay. So this is the first law of reflection. According to the first law of reflection, you have the incident ray, the reflected ray, and the normal all lie in same plane. I'll just show you, I'll just get you acquainted with these terms. According to the second law of reflection, it states that the angle of incidence,
Equal to the angle of reflection.
yeah, the angle of incidence is equal to the angle of reflection. Right. So these are the two laws of reflection. I'll just show you what they are talking of here. So consider a plain polished surface first of all. So just to understand this, we are considering a plain polished surface.
Sir, can I explain that, sir? Can I explain?
Okay, who wants to explain?
Me, sir, Pranav.
Okay, Pranav, explain.
So once can you go back?
Yeah,
Sir,
just 1 minute.
sir,
Yes, Pranav.
once draw the incident ray, sir.
Okay,
Like
I
the
draw here.
light coming from a source.
Okay, so this is the incident ray.
So, and it reflects back at the same point, sir, from the normal.
No. Okay, so this red line is the normal. Right.
So, if we make this is like this angle is equal, sir.
Okay,
The
the
angle
angle.
of reflection and angle of incident ray is equal, sir.
Okay,
Like
so
if
let
it is
this be.
30 degrees, it is also 30 degrees, sir.
Okay, so I'll just explain everyone. So see, actually Pranav is not able to go with, since the position, all the things have not been marked. Okay, so let this be your incident ray, this be your reflected ray, and you have this ON is the normal. Normal means a line perpendicular to the surface at the point of incidence. Okay, so normal is a line which is perpendicular to the surface at the point of incidence. So this is normal. That means this normal is making 90 degree with the mirror. So let this be the mirror, and let the name of the mirror be MM prime. This is our angle of incidence, and this one is our angle of reflection. All right. So we have angle of incidence, angle of reflection. Got it? So the angle of incidence is the angle formed by the incident ray and the normal, and angle of reflection is the angle formed between the reflected ray and the normal. So this is our incident ray. This one is a reflected ray. This ON is the normal. Right? So we have angle of incidence, that is angle I is equal to angle R.
Sir,
Yes.
if they gave this in algebraic expressions also, we can equate them. No, have to get the value, no, sir. We can equate
Which
them.
one?
Like if they are given in algebraic expressions also, we can able to equate them, no, sir, to get the
Yeah.
angle.
Yes. Okay, so see, try to understand. This one everyone knows, but we are here to understand something extra. Okay. So this angle, I will talk of some other angle also. The angle formed between the incident ray and the mirror, this is called as the glancing angle. What angle is this? Glancing angle. All right. Then you have another angle which we call as the angle of deviation. So what do you think should be the angle of deviation here? See, have you heard anywhere these terms? No. The angle of deviation. The word deviation means to divert. All right. So here, the angle of deviation, it means by how much degree has the angle of incidence been rotated. So see, this is the line in which the angle, in which the incident ray was traveling, and now it has been bent through this. It is now moving towards the reflected ray. So I can say that it has bent by this much of the angle, which I call as angle of deviation. represented by the symbol delta. This is our angle of deviation. Work हो गया. हो गया. Office
Sir?
complete हो गया. Yes.
So the reflected ray and the angle of deviation both are the same.
No, they are not the same. The angle of deviation.
Distance.
Okay, no, just like this. Try to understand this. Suppose at some time you are given the angle between the mirror. Let the angle between the mirror and the incident ray be 40 degree, right? So if this angle is 40 degree, what will be the angle of incidence? Yeah, what will be the angle of incidence?
Sir, 50 degrees.
60 degree?
No, sir, 50.
50, all right. Then the angle of incidence will be 50 degree. What will be the angle of reflection?
45 degrees, sir.
How much?
45 degrees.
No, angle of reflection.
50 degrees.
50 degree. The angle of incidence is always equal to the angle of reflection. And the angle of deviation. What would be the angle of deviation?
40.
No.
Sir,
So
60.
this whole is making
80, sir.
80. Sir, 80.
yeah, angle of deviation here would be 80 degree. Got it?
Yes.
Okay, so we'll continue with this in the next class. This is what someone was referring when wanted this. So it's here.
Oh,
All right.
done, sir.
Okay. Okay, bye everyone. We'll see you again in next class.
Thank you, sir.